Hello, so this is CSS332 microcontroller and application project, and in this project where we want to name our project to Gyro Razor with Unity game engine. So as it obvious, there will be a racing car model with Unity game engine, and we will use gyro sensor with Arduino to control the game. This is table content, so there will be an introduction about our project, and we will explain our project overview, and my friend will, who is responsible for the sensor to code mapping, he will explain about that, and will be implementation of our project and the project demonstration at the end. So how do we got this idea? So me and my friend who do this project together, we both enjoy playing video games. So uh, we want to do a video game project for our microcontroller. So first of all, there's so many popular games that feature video control mechanism rather than pushing button from the controller. So there's famous game controller like PS5 Duet, and so in that uh, controller you can tell the controller, and maybe you can touch or swipe down or swipe up, or you can even blow the controller to control the game character in the PlayStation. So we like that concept, and we want to implement, and we want to test that concept in our project. So we decide to create a controller that use gyro sensor and control the game character. And the game will be a racing car driving games using gyro sensor. So the approach is Arduino IDE is a great IDE. It's very easy to use, but it lets serious coding features like uh, dashboard or graphic. So those kind of limitation can be we can connect other IDE and make games from that IDE. So we choose Unity to make a game and use library to connect with Arduino IDE and Unity game engine. So from the Arduino part, we use serial command library to send data from the gyro sensor to the and capture with Arduino IDE and send it to the Unity engine. And in the Unity engine, we use .NET Framework Standard 2.1 to create game and 3D objects, and we use projection and motion in the Unity using .NET Framework. Our project has mainly two parts. The first one is Arduino Uno, which consists of 80 mega 328p controller, and the second one is the game software itself. I would like to I would like to explain about how do we send data to the Unity engine. First, uh, we capture coordinate such as X, Y, and Z from the gyro sensor and utilize serial command library in Arduino IDE and transmit those data to Unity engine. And within the Unity engine, we employ a built-in library name called system.io.pol, which is receive data from outside sources and outside IO port, and then we interpret and integrate it for the controller, such as turn left, turn right, or maybe go backward. So this is circuit diagram. Uh, First, we have Arduino Uno R3, and then we use from A2 to A5 port for the uh, OLED display, which will display the speed of our car, and this is NPU 6050, which is called a gyro sensor. We got coordinate data from the gyro sensor and sent to the controller. And in the upper part, we have a buzzer which will make a sound when the car collide with a wall or an object. And then there will be two LED lights. The red one will turn on when the car stop, and the green light will turn on when the car is going. And there will be three switches. So the first switch is used for the rear, and the middle one used for the backward, and the switch 3 used for the drive forward.
Our Gyro Visa project consists of three main scripts. The first one is Gyro Visa, which is an Arduino script. The second one is Arduino Info, which is a C# script. It is responsible for receiving and sending information to the Gyro Visa script. The last one is Car Controller script, where it receives information from the Arduino switch and control the movement of the car. First of all, we have MPU 6050 gyro sensor. The Arduino Pro sends this sensor information to the Arduino input script, and the Arduino input script receives using three variables. But we only need X information to simulate the real world car steering wheel. I added test zone to limit the movement of the gyro sensor. We have three switches, which is forward switch, backward switch, and the brake switch. The forward switch, when we press the forward switch, the green LED lights up and send information to the Arduino input script. Also, when we press the backward switch, we send backward command to the Arduino input script. And when we press the brake switch, the red LED light up just like in the rear car, and send the brake information to the Arduino input script. The Arduino input script receives this information and add it into variables. Also, the Arduino input script has return statement to be accessible by the car controller script. The car controller script receives this return statements, functions, and uses to control the car. Also, when the car collided, we send a pass command. This pass command is used by the Arduino script. When the pass command is sent, the buzzer light is turned on, and make a sound. Also, we have the accelerometer, which basically use the speed of the car, and we send it to the Arduino script using the aura command. We limit the sending delay to only 2 seconds, because sending the aura information every frame is set for optimization. So when the aura command is received, we have the aura update functions, which adds information to the accelerometer and every 2 seconds.
Đây.